using technology to reverse the effects of stroke. Welcome back to Techstination. I'm Fred Fishkin. Joining us from iRegained, based in Canada, is CEO Vineet Johnson. Hi, Vineet.
Good morning, Fred. Great to be here. Thank you for this opportunity.
Terrific. Well, you are a neuroscientist with training in physiotherapy using technology to help stroke patients regain the use of their hands. Tell us more about what you're doing.
Thank you for the introduction. iRegained stands to aid in improving hand function in individuals after a stroke. So if you think of the word stroke, most people would have known something about stroke. In a simple word, a part of the brain is damaged, and as a result of that damage, their hand function is compromised. There's nothing wrong in the hand itself, but the connection from the brain to hand is lost. We at iRegained use advanced technology, advanced engineering, and deep neuroscience research to help restore hand function through a process called neuroplasticity. Does that give you a good introduction?
Sure. And so this is, we're looking at a unit that's in your background there, and we'll look at more images and video. But how does this device is called My Hand? Is that right?
You're correct.
How does it work?
So the My Hand is a advanced customizable device aimed at improving hand function. So what you see in the device in my background, the teal colored part at the back represents the area where the individual's arm goes in. The way the device is designed, it's designed in such a way that the device can go as close to the patient as possible. In other words, as a result of stroke, the hand can curls up like that. So no matter what level of spasticity or tightness they have in their arm, the device will accommodate to that individual. And once they settle down, inside, like when you open the hood of the device, there are 5 slots, 1 slot for each finger. And you close the hood, and the tablet in front of them is very easy to use. 2 or 3 taps, it gets them to where they need to be. And on a very granular level, the tablet would give them instructions on what they need to do step by step. So if an individual, for example, can move only 3 millimeters, then the device will give them the required force, required movement for those 3 millimeters. The other important factor to note here, they cannot see their hands. They have to look at the tablet and use the feedback from the tablet so that they can do what they need to do and train their fingers. The second factor, at every step of the way, there are voice interactions that they could use as a help mode, or there are animated characters who would come and give them instructions on what they need to do. There is also a coach who's there to say, come on, keep going, keep going, keep going, which they could choose to use or choose not to use.
What are the realistic expectations for this in terms of the results? What should people know?
So what people should know are 3 important factors. Number 1, this targets hand function at a very granular level. How much they will get better depends on how damaged the brain was as a result of the stroke. The second part, how long since the stroke. In other words, if someone had a stroke 10 years ago, as opposed to someone who had a stroke 2 days ago. The earlier you start, the better the results. The third factor is intensity. And intensity is key in any stroke rehabilitation. So if you were to ask me a very simpler question and a simpler answer, what should people know? For patients that start with high function, in other words, the fingers can move a lot, but they cannot do anything with it, they will gain a lot in a very short time. The second category of people, what we refer to as moderate patients, where there is very minimal, there are a certain amount of movements, but not a lot, they will also improve quite significantly. The third group of patients that we refer to as low function individuals, for them, therapy might be like 1 to 2 years of therapy for them to improve over the time. In all categories, the focus is function. We have 16 protocols. Each protocol refers to a specific function. For example, there's one protocol called squeezing the ball. In other words, it's requiring the fingers to move in that pattern. A second one is holding a plate. It holds the plate and you're trying to move the plate. Third, for example, holding a pen. So every protocol is focused on a specific function. When they graduate from the protocol, they've achieved a particular function.
And at the moment, you're designing these to be used in physical therapist offices or medical facilities. Tell me about that and what the future may hold.
So our initial approach to the marketplace would be a B2B business approach, where we sell the device to rehab centers, outpatient rehab centers, outpatient clinics, occupational therapy clinics, physiotherapy clinics. And as the device gets well adopted into those centers, patients would start to ask, if you look at the rehab landscape, there's only so many hours of therapy they could receive, 3 weeks or 4 weeks or something along those lines. If patients want to continue after that, there has to be a second pathway. So we will transition into a B2B2C business model as the progress happens over the time.
Meaning consumers would be able to purchase these. Tell me what your thoughts are about insurance coverage, things like that, and how expensive this might be.
So let me first answer the question without the insurance. The device costs approximately $10,000. Patients can buy for $10,000 out of pocket, or they could lease or rent the device for certain periods of time. And once they are done using it, they can return the device back to the company. If they buy the device and once they're done using the device and they want to get rid of it, the company is happy to buy back. Now let's go to the insurance side of things. At this point, in a hospital or a clinic, the services provided by the clinician is reimbursable using the device. But it's not reimbursable for the individuals to use it at home. One of the things we are doing right now to make the device more accessible is we are trying to work with insurance companies to enable such an option, because that provides the insurance company a big incentive. For example, right now, once the stroke patient goes home, the insurance company might have to provide them with physiotherapy or occupational therapy services at home. They might have to send a health guide who will go home to help with their everyday activities of daily living. And these are services that they have to provide for 8 to 10 years after the stroke. If a segment of this population can clearly get better and be independent, that provides a huge incentive for the insurance companies to provide those reimbursement as well. But that's not something that's happened already. We are working on it. But to go back to the first part, in a hospital, rehab center, outpatient clinic, the current system or current CPT codes, they call it, is already approved for reimbursement.
How well does this work? And there are obviously people have been undergoing therapy for quite some time, for many, many years after following a stroke. So how much better is this? What do we know?
So I'll answer this question in two parts. There are lots of devices out there in the marketplace, in the research center, and so on. And they belong to 2 or 3 categories. The first category, you would call them a glove or passive devices like squeeze ball, elastic bands, and so on. The second category are electrical stimulation devices. And the third category are robotics. So if you look at the first category, they are passive. They themselves don't do anything to the individual. The second category are electrical stimulation. Now your hand, if you look at it, has about 25 joints and 35 muscles. If you really want to stimulate all of those muscles, you need electrodes in every single muscle. There's not a single stimulation device that's out there that neither can they provide that level of stimulation, nor can they provide the control systems. It's a very artificial stimulation. which does not provide long-standing neuroplastic changes to the brain, particularly with the hand. There are some evidence to indicate that there are improvements in shoulder and so on. The third category is robotic devices. There are some robotic devices that purely provide robotic movements, and some provide assistive movements. And in all three categories, the common factor is the patient is not doing anything. If you look at it from a different perspective and say, if I go to a gym and I want my biceps to get better, I have to pick up a dumbbell and I have to move that dumbbell up and down X number of times to increase the bulk of that muscle. In other words, the patient has to do it. Very similar to a baby learning how to pick up objects step by step by step. So what we do at iRegained is completely different from every other system out there. At a very granular level, millimeter by millimeter, step by step, a function is retaught to the patient from scratch. And that's the unique factor. Now, let's go down to the other side. What does the research say? Our first study was a pilot study done a few years ago. I think we had 8 patients participating over 6 weeks for a total of 18 one-hour sessions. There was statistically significant functional improvement in both objective and subjective. Objective, where the clinician looks at the results and says they got better. Subjective is where patients were interviewed on a survey and they felt they got better as well. And anecdotally speaking, I think 3 or 4 of the patients were able to write for the first time since their stroke. One of them was able to play the accordion for the first time since their stroke. One of them even went back to work as a HVAC technician. And that was a few years ago. As of last week, a study was completed at Baker's Hospital in Toronto. It's early. We have not published the results yet, but every indication looks like all 11 patients who participated in the study over a 3-week period for a 15 one-hour sessions, all of them got better at varying levels. Functionally, they got better. In a lot of studies, if you look, they will talk about, the muscle strength improved or the fingers can move a little more, but function is the key factor. The patient wants to know, I couldn't pick up a coffee mug, now I can. And in this case, that's what improved. And that's where our difference comes from.
Very interesting. Let's take a look at a little bit of video to explain this further.
Every year, 50 million people get a stroke worldwide. That is 1 person every 2 seconds. Most survive, but 70% of the survivors have some level of paralysis in their hands. This means they can't do basic activities of daily living, like eating, grooming, and dressing independently. But we have good news. Our brains have a natural ability called neuroplasticity. Neuro refers to the brain, and plasticity refers to the ability to learn and change. We at iRegained leverage neuroplasticity to rewire the brain with our MyHand system. The MyHand system is affordable, portable, and clinically effective, unlike other stroke rehabilitation therapies such as ineffective squeeze balls or expensive robotic systems. The device has 16 different exercise regimens, each tied to a specific daily living activity prioritized by the patient. So how does it work? Very simple. Step 1, a therapist will do an assessment of the patient's hand function. Step 2, the patient specifies what activities are most important to them, like holding a fork. Step 3, the therapist customizes the fit of the device to the patient's hand in their home. The therapist can assist a patient to position their fingers into the appropriate finger cups. Then they select the programs that meet the patient's goal. How will I know how to use it? The display screen interface guides you, the patient, to insert your fingers into the 5 finger cups. You will follow directions to work through the personalized preset therapy regimens with simple and fun games. You won't even know you're exercising. How will I know if I'm improving? As you work on the exercise regimen, your display interface will show progress towards your goal. Your therapist will receive real-time feedback and brief you. Gradually, you will recover hand function by enhancing the neuroplasticity of your brain. This process is patient-driven and therapist-supervised. Know that you now have a solution. You can regain function. You can live independently. My Hand System. Your recovery is now in your hands.
Vineet, what is it that led you down this path, career-wise and personally?
Personally, it's a very interesting journey. 30 years ago, I was very privileged to interact with a remarkable neuroscientist by the name Marcus Devanandan. Back then, I was a physiotherapy student, and he was doing research on monkeys and how the monkey's brain controlled the monkey's hand. And I was fascinated by how granular that control was. Ever since I've been, lack of a better word, obsessed with understanding the whole word control. How does the brain control the body? How does the brain control the hand? And what happens when part of that brain is damaged? How is that control lost? And how is that control regained? And that was my quest over many, many years. And that led me to trying to understand what is stroke rehabilitation. As part of my doctoral program, we were working with multiple robotic devices, 4 different robotic devices in total. And the challenge with all the robotic devices were, A, they were very expensive, very complex, hard to maintain, and most importantly, most people cannot afford the services that you provide using these devices. If most clinics and hospitals cannot afford it, most patients don't even get a chance to even look at it. So my goal then was to come up with a device that would be affordable. In other words, average individuals should be able to access these devices. The second aspect was portable. In other words, it's small and easy enough that an individual can use the device by themselves, operate the device by themselves. The third factor was clinically effective. Most devices out there, even today, if you talk to any physiotherapist or occupational therapist, you'll realize that they are not really functional. And patients are not happy, particularly with ones that talk about hand rehab. So my larger goal was trying to get something that can actually profoundly change the functional abilities of the patient. So in 2016, I decided I'll quit my job and get on this venture. I took a year off. And since then, I've hardly gotten any time off, probably taken a few weekends off, and be working on this device. I would say from July 2017 till date, it's been a crazy journey to get through that. Today, we've built a phenomenal team of engineers, programmers, and kinesiologists. Together, we've made this happen. Our beta prototype is now ready for clinical deployment. Soon we will have some of these devices going out there. And to go back to the fundamental question you asked, what made me go this way? Every time a patient makes a movement for the first time or has a new function for the first time, you see a tear in their eye. That brings a tear in my eye. I just hope I can cry a lot and bring more such tears and make a difference in more people's lives.
Well, terrific. And congratulations on the innovation and what you're doing. Where can people go for more information?
They can access our website, www.iRegained.ca. They can contact us anytime through info@iRegained.ca. And we would be happy to provide any and all information they would like. We are at this point initiating collaborative pilots across Texas and California. If anyone would like to, any clinic or a hospital that's interested in trying our device, we'd be very happy to collaborate with them. And there's also a phone number available. They can give us a call and we'd be very happy to respond to them with any information they would like.
Terrific. Again, it's iRegained.ca. Vineet Johnson, thank you so much for taking the time with us.
Thank you so much, Fred. It's such a pleasure.